All right, guys, today we're going to look at inequalities and more importantly, interval notation. So let's just start with it. Graphing inequalities. You should be slightly familiar with it. We use an open dot for these two symbols, the less than or the greater than symbols, and we use a closed dot for less than or equal to or greater than or equal to. Now, with interval notation, this is going to be new for most of you. We use parentheses, infinity symbols, brackets, and commas to represent a set of numbers. We're going to do a lot of practice with these because it is extraordinarily important. This is how you're going to represent sets of numbers, okay? Whenever we have an open dot or a less than or greater than symbol, we use parentheses. That's these guys. We use some of these, parentheses. That means it does not include the values on the ends. It's an open set. Now, if we do include it, if we have a closed dot or a less than or equal to symbol or a greater than or equal to symbol, we use brackets, straight brackets, not curly brackets. So that's what those look like. Brackets means it includes. Parentheses does not include. So I find every year some of you guys don't know how to read. Well, that's every year, but you don't know how to read your symbols. You don't know what they mean. So let's just go with it. This is your less than symbol. Less than. That means the number on the left of the symbol is smaller than the number on the right of the symbol. Now here we have the less than or equal to. The line underneath represents equality. So number on the left is smaller than or the same as the number on the right. I missed the "the," but whatever. Next, we have the greater than symbol. The number on the left is larger than the number on the right. So let's make sure left, right. Make sure you know your left from your right. And finally, we have the greater than or equal to symbol. Again, it's got the greater than and then a line underneath for an equal sign. So it's greater than or equal to, so either one. The number on the left is larger than or the same as the number on the right. Okay, so those are your symbols. Make sure you know them, make sure you can read them, make sure you know what they mean. If you can't, well, sucks for you. Figure it out. So let's go ahead and just get started with this. We're going to graph these inequalities. I'm pretty sure you've done this in the past. So we're going to start by just sticking something on here. So there's no numbers, so we can go wherever we want. I can call this 8. Could call any one of these 8 if you really want to. It doesn't matter. But let's read it. It says x is greater than or equal to 8. So it's got the equal to, so I'm going to use a solid dot. And it's greater than that, so it's to the right. The numbers on the right of the number line are bigger than the numbers on the left. And it goes on forever, so make yourself a nice little arrow. Now here is the key, interval notation. If you're looking at your number line, it tells you exactly what you need to put. I've got a solid dot, so I'm going left to right because we're in America. We read left to right. So starting from left to right, the first thing I see is a solid dot. So that means I need a bracket. And I open the bracket. Next, it's the bracket on the number 8. So I'm going to put the 8. And then I'm going to put a comma to separate. It goes on until, well, what does it stop at? It doesn't, so that's an infinity symbol. It goes on forever. Oops, didn't hit the infinity symbol apparently. 1 second, my bad. There we go, infinity. Now, let me ask you this. Can you ever reach infinity? Let's think about it. What's the biggest number you know? How about a Googleplex? Well, is there a number bigger than that? Yeah, add 1 to it. What about bigger than that? Yeah, add 1 to it. So you can think of the biggest number you can, add 1 to that, and then you can add 1 to that and keep on going forever. There's no end. You can never actually reach infinity. So can we include a number that we can't reach? No, we can't. Infinity is always in parentheses, positive or negative infinity, doesn't matter. Can't reach it, it's in parentheses, because you can't include something you can't reach. So this is the interval notation for this set notation right here. So this is including 8 all the way up to infinity, not including. So everything between 8 and infinity, but it includes 8, not infinity. Look at the next one. Let's stick a -1 right here. Does it matter? No. There's no numbers. You can put wherever you want. Now let's read it. It says A is less than -1. So -1 is the biggest thing I should have, because A is smaller than it. So I'm going to go less than left. And I got a nice little arrow. Goes on forever, whatever. So again, to put it in interval notation, you can read your graph. What's the first thing I'm starting with? Well, it's going forever and ever and ever. So that's an infinity. And remember, we cannot include infinity ever. So then the next thing I have is this -1. And it does include that, so I'm going to stick a bracket on there. All right, so we're going to do a bunch of examples. We're going to solve some inequalities and put them in interval notation and graph them. You must be able to read and write interval notation. Here we go. So basically, to solve an inequality is the same exact thing as solving an equation, with one minor difference. Anytime you multiply or divide by a negative number, you must flip the inequality. Now let's think about why that is true. If you're on a number line, and let's say here's 0, 1, 2, 3, and you multiply that 3 by a -1, well, that's going to go in the opposite direction. 3, 1, 2, 3, -3. The negative sign is a direction. And whenever you multiply by that direction, you have to change your direction. So if I were less than 3, if I were this way, and multiply by negative, well, that had to change the direction of my arrow to that way. So that had to be greater than 3. Also, if you think about it, if we have -x is greater than 3, and to get this by itself, I'd have to divide by a -1 or multiply by a -1, either way. I'd have x is, if I didn't flip the inequality sign, greater than -3. Well, is -x greater than -3, or is x greater than -3? They can't both be greater than -3, right? So instead, we flip this symbol. And another way we could have solved this one is by adding x to both sides. I move my face. I'd get 0 is greater than 3 plus x. So I need to subtract 3, -3 is greater than x. So if we read this, then -3 is bigger than x. Now, we usually write x on the left side. So if we flip that around, we'd have to follow what the symbol says. It says x is going to be less than. See, this, which is bigger? The -3 is bigger. So x has to be less than -3. So either way, whenever you're dealing with negative signs and inequalities, multiplying and dividing, just make sure you flip your symbol. Make sure you flip the inequality symbol and you're good to go. Let's practice. So again, we're going to pretend that this is an equal sign and just do what we got to do. I'm going to subtract 7v from both sides. You could subtract 5v, doesn't matter to me. So I get -2v plus 1 is greater than -17. Subtract 1, -2v is greater than -18. Divide through by a -2. So I get V over here, I get 9 over there, but don't forget, we divided by a negative, so this thing's got to flip. It was greater than, now it's got to be less than. So V is less than 9. Start by graphing that. Let's stick a 9 right here. I mean, you can put more numbers if you really want to. Doesn't matter to me. There's my 9. Oh no, what's wrong here? I put a solid dot. But guess what? It doesn't include it, so you better put an open dot. Now I've seen some notations where it just goes ahead and puts a parenthesis on the numbered line. You can do that if you want to, I'm fine with that. But for these purposes, I'm gonna put an open dot and a closed dot. Then you just shade, throw some shade on there. Boom. It's graphed. Now what? Interval notation. Read the graph. Where are we starting? Again, we're going from left to right. So the first thing I'm going to is an infinity, but it's a negative infinity. From negative infinity all the way up to 9. And we don't include that one. So this is a open set. Oh, 1 second, please. Okay, I'm back. So yeah, this is an open set. We got an open parenthesis here, we got an open parenthesis there. A lot of them we've been dealing with were clopen sets, one closed, one open. Doesn't really matter if you know the names or not, just know what they mean. We don't include negative infinity, we don't include 9, it's everything between. Now, I think I might have forgotten a negative sign, so let's go back and, oh, yep, I did. My B. It's not a positive infinity there, it's a negative infinity there, so don't forget your negative sign. So back on this one, number 2, that's negative infinity to negative 1. Sorry. All right, negative infinity to 9. Let's look at this one, let's see what happens. So I'm looking, we got the distributive property going on. 12p plus 52 is greater than negative 8 plus 4p. And then we get our p on one side. It could be either side you want, doesn't matter. I'm gonna get on the left side because at the end, we do want our variable on the left side. That's standard notation. So we want to get our variable on the left side of these things. So I'm left with 8p plus 52 is greater than negative 8. Got to get rid of that 52. So 8p is greater than negative 60. Divide by 8. And we get p is greater than, use your calculator, simplify that. What's that, 15 over 2? Negative 60 over 8. Negative 15 over 2. Oh no, how on earth do I write that on a number line? Well, take your calculator and make it a decimal. It's 7.5. Negative 7.5. So I'm gonna put negative 8 right there. Actually, I'm gonna move it over a little bit and put negative 9 right there. Negative 8 right there. Negative 7 right there. Negative 6, etc. Who cares? So negative 7.5 is right here in the middle. So I'm gonna put open circle, because look right here, it's greater than. Right there in the middle. Has to be absolutely perfect. JK. Just stick it in the middle there, ish. So we got an open circle right there. You can even write underneath it negative 15 halves if you want to. Remember, for this class, Decimals are no-no unless I say so. And then we're just gonna shade. It says P is greater than this number right here. So I'm gonna shade to the right, all the bigger numbers. There. So interval notation, let's do it. Going from left to right, I'm starting with an open circle. So that's that. And that open circle is at -15/2. So I'll put that. And it goes out all the way until forever, so infinity. This would be a positive infinity because it's on the right. Negative infinity is on the left. And again, we can never, ever, ever include any infinities. Always use parentheses. All right, that's it for that one. Look at the next one. Okay, we got a fraction in here. So what do? Same thing we always do. LCD. There's only one D, so it's our LCD. It's going to be -2. Multiply each term by your LCD. I'll do -2 times. This whole thing is one term because the fraction bar is a grouping symbol. You can put in a big old set of parentheses if you want to. And this is going to be less than, and we multiply -2. Oh, wait. We're multiplying by a negative, aren't we? What do we have to do? We flip the inequality sign. Don't forget, when you multiply or divide by a negative, you must flip the inequality symbol. Each time, every time. You might flip it 5 times in a single problem. Probably not, but you might. Just keep an eye on it. Anytime we multiply or divide by a negative, you have to flip the sign, the direction of your inequality symbol. So those just cancel out. I'm left with 4 plus, you could distribute now, but I'm not going to. I'll put multiple steps for you. It's greater than, and I guess I will distribute this one, -2w minus 14. Distribute, combine like terms. Same old steps. Just pretend it's an equal sign until you're multiplying or dividing by a negative. It's the only difference. All right, 4 minus 50, that's -46. Combining like terms there. Then I need to get my numbers on one side, my variables on the other. Doesn't matter which. I'm going to go ahead and get my variables on the left because that's standard notation for interval notation. For solving intervals for set notation. I'm going to add 2w to both sides, and to save space since we're running out of it, I'm going to go ahead and add 46 to both sides as well. That way my numbers will be on the, or my variable will be on the left, my non-variable will be on the right. Okay. -46 plus 46 is nothing. 10w plus 2w is 12w. It's greater than, that's gone. That's going to be what, 32? Another fraction. Or it's possible I messed up somewhere. -14 plus 46, 32, yep. Divided by 12, that's going to be not fun, 8/3. Yeah, that's not too terrible. So divide by 12, and as you saw, I just used my calculator and I got 8/3. So it says W is greater than 8/3. So up here, I'm gonna go back to my calculator. 8/3 is like 2.7-ish. So I need to have, how about, let's do 1, 2, 3, 4. So it's gonna be closer to 3 than 2, so I'm gonna put my open circle right here. Again, doesn't have to be perfect. 8/3. I'll just stick that underneath there. And I'm a shade. It's going to be greater than 8/3. I'm going this way, to my right. Done. It's graphed. Read your graph, put it in a rotation. Oops, thirds, not halves. Open circle, use a parenthesis, 8/3. Goes all the way out to infinity. It is a positive infinity. That's it. And I think, yeah, we'll just talk about set notation. That'll be it. So far, we've just done integral notation in the graph. There's one more thing, set notation. It's just another way to represent it. So it looks like this. Curly brackets represent a set of numbers. So it's the set, and if we read this, it's the set of x such that x is greater than 5. The set of x such that x is greater than 5. Okay. I'm more worried that you know integral notation. You may see set notation sometimes. Most common is integral notation. But if you look at set notation, it's pretty self-explanatory. X is greater than 5, x is greater than 5. She's got some extra fancy stuff around it. So don't be like, oh, I don't know what that means. It just means x is greater than 5. All right, I'm gonna split this video in two. We're gonna work on inequalities for 2 days. So I'll see you in the next video.